Hello and welcome. Today, we're going to pull back the curtain on one of the most powerful systems in modern software, Kubernetes. We're going to break down its core architecture piece by piece so you can really understand how it all works under the hood. Let's get started. So, to really get why Kubernetes is so important, we first have to understand the problem it's designed to solve. You see, modern applications aren't just one big program anymore. They're often made up of hundreds, sometimes thousands of tiny, independent services all running in containers. Now, trying to manage all of that, making sure they're running, that they can find and talk to each other, that they can scale when needed, well, that's a massive headache. So how do you deal with that kind of complexity? And that's where Kubernetes comes in. It's really become the industry's go-to answer for this problem. It's what we call an orchestration system, and its whole job is to take that potential chaos of containers and wrangle it into something structured, reliable, and manageable. All right, so here's how we're going to break this down. We've just touched on the problem modern applications face. Next, we'll look at the Kubernetes cluster from a high level. Then, we'll dive deep into its two main parts, the control plane and the worker nodes. After that, we'll see how you can extend the cluster's functionality, and finally, we'll wrap up with the key takeaways from this architecture. Okay, let's dive in, starting with the big picture view. What exactly is a Kubernetes cluster? Well, at its simplest, it's just a set of machines, which we call nodes, that are all networked together to act as one single, powerful computer for running your applications. And this diagram really shows you the fundamental design at a glance. You'll notice it's split into two distinct parts. Over here, we have the control plane, which you can think of as the brain of the whole operation. And on the other side, we have the worker nodes. They're the brawn, the muscle that actually does the heavy lifting of running your applications. And, this separation of duties? That's a core idea you'll see again and again in Kubernetes. So let's zoom in on that brain, the control plane. Its entire job is to make all the important decisions for the cluster. It keeps track of the state of everything, it reacts when things change, and it makes sure that the whole system is running exactly the way you told it to. Right at the heart of the control plane, you've got the API server. The best way to think about it is as the front door to the cluster. Anytime you want to interact with Kubernetes, or anytime components inside the cluster need to talk to each other, they have to go through the API server. Basically, nothing gets into or out of the cluster's brain without going through this front door. Okay, so if the API server is the front door, where does the system actually store all its information? That's the job of etcd. It's a key value store that acts as the cluster's memory. It is the single source of truth for everything, all the configurations, the current status of every component. All of it lives in etcd. That's why keeping it safe and backed up is absolutely critical. All right, so let's say you want to launch a new part of your application. In Kubernetes, we call the smallest deployable unit a pod. Well, when you create a new pod, something has to decide which of your many worker nodes it should run on. That's the job of the kube-scheduler. It's like a matchmaker, looking at the pod's needs and finding the perfect, healthy node to host it. And this isn't just a random guess. The scheduler is actually pretty smart about it. It follows a clear logical process. First, it spots a new pod that doesn't have a home yet. Then it looks at what that pod needs, like CPU and memory. It filters out any nodes that can't provide those resources. And finally, from the nodes that are left, it scores them and picks the best possible fit. Next up, we have a really cool component called the controller manager. The thermostat analogy here is perfect. You, the user, set the desired state. Let's say you want 3 copies of your application running. The controller manager constantly observes the cluster's current state. If it only sees 2 copies running, it takes action to start a third one. It's always working in the background to make reality match your desired state. And this controller manager isn't just one thing. It's actually a collection of different controllers, each watching over a specific part of the system. For instance, the node controller notices when a worker node suddenly goes offline. The job controller makes sure that a task you only need to run once actually finishes. Each one is a little automated process dedicated to keeping one part of the system in check. And the last piece of the control plane puzzle is the cloud controller manager. Now, this one's optional, but it's essential if you're running Kubernetes in a public cloud like AWS or Google Cloud. It's kind of like a special adapter that knows how to speak the language of your specific cloud provider. So it can do things like ask for a cloud load balancer or provision a new block of storage. Okay, so that covers the brain of the operation. Now let's talk about the muscle. We're moving on to the worker nodes. This is where all the action happens. It's where your application pods are actually deployed and run. On every single one of those worker nodes, the most critical component is the kubelet. The kubelet is an agent that's constantly talking back to the API server in the control plane. It gets its instructions, like start this pod or stop that one, and then it makes sure that the containers inside those pods are up, running, and healthy. It's the control plane's representative on the ground. So your pod is running. Great. But how does it talk to anything else? That's where kube-proxy comes into play. It also runs on every single node, and you can think of it as a local network manager. It handles all the complex network rules needed to make sure traffic can get to your pods, whether that traffic is coming from another pod or from outside the cluster entirely. And of course, at the very bottom of all of this, something has to actually run the containers, right? That's the job of the container runtime. This is the engine, software like Containerd or CRIO. The kubelet tells the container runtime what to do, and the runtime does the heavy lifting of starting, stopping, and managing the lifecycle of the actual containers. So all the pieces we've just talked about, they give you a working, functional Kubernetes cluster. But the real power comes from its ability to be extended with a whole ecosystem of add-ons and plugins that provide extra functionality. These add-ons are what bring in some really crucial features that you'll almost always need. For example, every useful cluster needs a DNS service, so your applications can find each other just by using their names. Other popular add-ons give you a web dashboard to see what's going on, tools to monitor performance, systems for collecting all your logs in one place, and more advanced networking. All right, let's pull back for a moment and recap what we've learned. What are the big ideas that make this architecture so powerful and so flexible? You know, this slide is a perfect example of just how flexible Kubernetes is. Even the control plane itself can be set up in a bunch of different ways. You could run it on its own dedicated machines, or even have Kubernetes manage its own control plane. But honestly, for most people today, the easiest and most common way is just to use a managed service from a cloud provider and let them handle the whole control plane for you. So if you're going to walk away from this remembering just a few things, let it be these 4 key principles. First, that clean separation of concerns, the brains managing the brawn. Second, the power of a declarative state. You don't tell Kubernetes how to do something, you just tell it what you want the end result to be. Third, it's a distributed system from the ground up, built to be resilient. And finally, it's incredibly extensible, so you can customize it with exactly the tools you need. So, we've taken a deep dive into the architecture, the what and the how behind Kubernetes. Understanding these moving parts is really the first major step. The next, of course, is putting that knowledge into practice. So my question for you is, now that you have this foundational knowledge, what are you going to build with it?